In this very short video, we are going to see a particular misconception. In general, the students think that when the two bodies are in thermal equilibrium, they must be in contact of one another. But this is a misconception. Two bodies in thermal equilibrium may be in contact or it may not be in contact. So I have written the heading in just as a question form. Is it possible for two bodies to be in thermal equilibrium if they are not in contact? The answer is yes. It is possible that two bodies are in thermal equilibrium even if they are not in contact. But how you can say that if two bodies are not in contact, even then they may be in thermal equilibrium? So let us see the explanation. And for explaining this very fact, let us consider two bodies. Let us say one body is A and another body is B. And we assume that TA is the temperature of body A and TB is the temperature of body B. Do you know what is the necessary and sufficient condition for two bodies to be in thermal equilibrium? Definitely you have studied in your course on thermodynamics the zeroth law. In fact, zeroth law says that two bodies A and B are in thermal equilibrium if I have written IFF, which means if and only if. That is necessary and sufficient condition. That is the necessary and sufficient condition for A and B to be in thermal equilibrium is what? This condition is TA must be equal to TB. It means if the temperature of the two bodies are equal, then you say that the two bodies are in thermal equilibrium. Nothing has been said for the contact. Only the condition is for temperature. So you can say that the necessary and sufficient condition for two bodies in thermal equilibrium is what? The equality of temperature is the necessary and sufficient condition. It means you can say that if the temperature of the two bodies are equal, definitely the two bodies will be in thermal equilibrium. But can this temperature of two bodies may be equal when the bodies are not in contact? Answer is yes. If two bodies are in contact, temperature may be same. If two bodies are not in contact, even then temperature of the two bodies may be same. For example, let us consider, you can see this figure. I have shown here a large heat reservoir. And when you say heat reservoir at temperature T, it means this temperature T is constant. This heat reservoir is of infinite heat capacity. So whenever heat will be lost by this heat reservoir, there will be no appreciable change in its temperature. So you can say that this heat reservoir is maintained always at a temperature T. Okay? Because why its temperature does not change? Because the heat capacity of the heat reservoir is infinity or very large. And let us put the two bodies A and B in contact of the same heat reservoir, as you can see in this figure. And the contact of A and B I have made diathermic contact. What does it mean? It means heat energy may flow from the heat reservoir to the body A and to the body B. So if the bodies A and B are at different temperature and their temperature are also different from the temperature of the heat reservoir, then what will happen? Since the heat reservoir is at large temperature, so heat energy will flow from the heat reservoir to the bodies. And this flow of heat will remain continue until the temperature of both of these bodies will become equal to the temperature of heat reservoir. So finally, in course of time, the temperature of body A will become equal to the temperature of heat reservoir, that is T, and finally the temperature of body B will also become equal to temperature of the heat reservoir, that is T. So I have mentioned it here, you can see. Now consider the bodies A and B are not in contact, as you can see in this figure, with each other, but in contact of a heat reservoir at temperature T. With passage of time, both bodies will attain the temperature of the reservoir. That is, finally, in course of time, temperature of body A, Ta, will become T, and that of B, which is Tb, also becomes T. So you can say in course of time, the temperature of body A and body B will become same. But are these two bodies in contact of one another? Answer is no. A and B are not in contact, but their temperatures are same. And you know, if their temperatures are same, then you can easily say that the two bodies are in thermal equilibrium, because the equality of temperature of two bodies is the necessary and sufficient condition for thermal equilibrium. Oh, so you can now say that it is possible to have two bodies in thermal equilibrium even they are not in contact. Okay, so I think this misconception is now clear to you. Okay, thank you very much.